everyone, we're going to identify and graph our polar equation r equals 2 sine of 3 theta. This is going to be a rose with 3 petals, and we're going to first use tests for symmetry to help us graph this. So the first one is we want to see if our graph is going to be symmetric with respect to the polar axis. And we do this by writing 2 equals sine of 3 times negative theta. We're substituting in our theta with negative theta. This is going to give us equals 2 sine of negative 3 theta. Since sine is an odd function, we can pull this negative out and bring it in front here. So we have negative 2 sine of 3 theta. Since these two are not equivalent, we don't get an equivalent equation. It means our test fails. Therefore, our graph is not going to be symmetric to the polar axis, x-axis. All right, let's try the line theta equals pi divided by 2. So basically for this one, we're going to be replacing our theta with pi minus theta. So we're going to have r equals 2 sine of 3 times pi minus theta. So just using this for substitution. This equals 2 sine of 3 pi minus 3 theta. I'm going to use my difference formula for sine and expand this and then evaluate. So we're going to have this equals 2, and then we have sine of 3 pi times cosine of 3 theta minus cosine of 3 pi times sine of 3 theta. All right. Now, sine of 3 pi is going to be 0, so this knocks this out. Cosine of 3 pi is going to be negative 1. So you have negative times negative 1, and that's going to be positive. So these two negatives make a positive. You're going to get this equals 2, this equals 0, sine of 3 theta, which does give me back to my original equation. So this test passes, and it means our graph is symmetric to the y-axis. And the pole, you just substitute in r with negative r, and clearly these two equations are not equivalent. Due to symmetry with respect to the line, we're going to assign values of theta to be in between negative pi divided by 2 and pi divided by 2. All right, so I set this up kind of already, and let's evaluate. This is our equation. In this case, usually I don't put pi over 4, but in this case it makes it a little easier to graph. So we're going to get 2, 0, negative square root of 2, that's negative 1.4 approximately, negative 2, 0, 2, square root of 2, which is approximately 1.4, 0, negative 2. So let's start with the graph. At negative pi divided by 2, we're going to get 2. So you'll want to remember this is symmetric to this line here. So I'll just kind of draw this dashed line. All right, so let me make this point dark. At pi over 2, it is 2. So I'll put that there. Now at negative pi divided by 3, we're at 0. So I'll put a 0 here. At negative pi divided by 4, which is this one right here, This is 7 pi divided by 4. That's going to go to negative 1.4. So that goes this way. All right, and then we have negative pi over 6 is at negative 2. And that's this one. Negative 2. All right, so we're starting at 2. Then we go to 0. Then we're coming through this point here and coming up here. Now at 0, we're back at 0. All right, so that's what we have so far. At pi divided by 6, we're at 2. So it comes back around to this. At pi divided by 4, which is right here, that's going to be 1.4, so that's getting close to 1. And then we're back at 0 at pi divided by 3, so it swings back. And then at pi divided by 2, it's at negative 2. So we're coming back up around, back down to negative 2 here. So if I graph this faster, we started here and we're going, this is how it's going. And that would be your rose with 3 petals. Thank you. Have a nice day. Bye-bye.